For this performance task, we aim to create a project that focuses on reducing vulnerabilities and increasing capacities to make affected infrastructures safer and more resilient for upcoming disasters. In this research, our group will prepare 3 points in order for us to reach that goal. And those 3 points are the specific things to focus on, response during and after the disaster, and the data to be gathered. Well, let's first go back to the first point, which is centered on what the specific things we have to focus in the building structures. The first one being structural integrity. The materials used and how a building is constructed is quite literally the foundation of a building. If it's cheap and poorly made, chances are, in the event of a disaster, it'll come crumbling down. That's why it's important to check if the materials and foundation of the building can survive natural disasters. Not only before, the state of the building should also be checked after a disaster to confirm whether it can still support itself for the next disasters. The next ones are building layout and emergency precautions. The people who engineer buildings must also consider the vents, electrical schematics, fire sprinklers, and of course, emergency exits. Emergency precautions or equipment are also needed in order to help the ones currently in the building escape when possible. The last ones for point number 1 are evacuation zones, speed, and efficiency. There must always be a place the people in the building will go to in order to avoid panic, confusion, and casualties, and in order to achieve a quick, efficient, and effective evacuation. Our second point centers around how the building's maintenance and response team should act during and after a disaster. During a disaster, prompt evacuation of employees requires a warning system that can be heard throughout the building. If there's no fire alarm system, they can use a public address system, air horns, or other means to warn everyone to evacuate. Sound the evacuation signal during planned drills so employees are familiar with the sound. The second priority is the stabilization of the incident. There are many actions that can be taken to stabilize an incident and minimize potential damage. Designing the building with adequate fire alarms helps, giving instant signals to move people to safety. The design of the building should also have easily visible stairs and entry and exit points. This helps in managing the crowd, which could possibly lead to stampede because of panic. After the disaster, containment of a small chemical spill and supervision of building utilities and systems can minimize the damage to a building and the environment. Rehabilitation and reconstruction of infrastructure must be done in order to restore the workflow of the existing structures and services, or upgrade them to meet the current needs. A developer should ensure proper drainage, especially in the basement parking, which is highly prone to flooding. Insulated electrical fitting will reduce tripping of electricity, which can otherwise be extremely fatal. Our last point is focused on the data that should be gathered in the post-assessment tests. The first being collateral damage. The amount, expense, and impact of the disaster to the people should be recorded in order to know which part of the evacuation or building went wrong or got destroyed, and where they should or it can improve upon. The head count of the people are also important in order to confirm the number of safe or missing people and casualties.